Set of square numbers. Is 3 a square number? Can we form a square with using 3 dots? Is 6 a square number? No. Is 7 a triangular number? No. So actually, we are talking about numbers that form, what do you call these two-dimensional figures? Polygons. So we call them polygonal numbers. All right. All right. Let's concentrate on the regular polygons. So what's the polygon with the least number of sides? Triangle. Okay, so we have triangular numbers. What's next? Okay. Again, we focus on regular polygons. So quadrilateral is more general. What's a regular quadrilateral? It's actually a square, so we have a square numbers. Okay. And what if we have 5-sided polygons? Okay, we have pentagonal numbers. And we also have hexagonal numbers, and so on. Okay. What's the formula for the nth term for the triangular number? 1/2 n squared plus 1/2 n. For square numbers, n squared. Now, I want you to do individual work this time. Can you solve for the nth term for the pentagonal numbers? And solve for the nth term for hexagonal numbers. Can you do it quickly? Any volunteers for the pentagonal? Actually, some of you were wondering how they look like. Pentagonal numbers would also start from 1. And then, of course, 5 is our first pentagonal number. We have 5 dots. And then what would be next? This is actually, we have a 2x2 array here, so we have 3x3. And then, that on top. So, they look like pentagons. And hexagonal numbers would look like this. So, we always start with 1, and then with 6 this time. So, that would be 1, 2, 3, 4, 5, 6. And then, next would be, this is 2x2, no? We get 3x3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And get 1, 2, 3, 1, 2, 3. So, these are hexagonal numbers. All right. So, who got the nth term for pentagonal numbers? Anyone? Yes, Melinda, what's your answer?
The answer will be 3/2 n squared minus 1/2 n.
3/2 n squared minus 1/2 n. Okay. How about for hexagonal numbers? Anyone? Betsy?
The answer is 2n squared minus n.
Minus n. Okay. What if I ask you, what's the nth term for a polygonal number of z sides? So I cannot use n-gonal number. So z sides. So this is 3 sides, 4 sides, 5 sides, 6 sides. What if I have a z-sided polygon? Z-gonal numbers. Let's just call them z-gonal numbers. In other words, can you see a pattern here? Yes? What's the pattern? I think it's not that clear yet. So let me rewrite this first. I'll just put the 2 here. So this becomes n squared plus n. Okay. Here, I want a 2 here. So what would be the coefficient of 2n squared? Another one here. 0, 0n. Okay. Okay, I want a 2 here. Minus 1n. Okay. I want a 2 here. 4n squared minus 2n. Do you see a pattern now? So if I have z here, what do I do? Of course, you have an over 2 here, and then this is 1, 2, 3, 4. So z, is it zn squared? For n equal to 3, it's 1. For n equal to 4, it's 2. For n equal to 5, it's 3. For n equal to 6, is 4. For n equal to z minus 2, n squared, okay, minus c. For 6, it's 2. For 5, it's 1. For 4, it's 0. For 3, it's actually negative 1, if we want to write minus n here. So what's the pattern? Z minus 4n. Okay, isn't that interesting? Yes. Okay, let me show you one more interesting thing here. What do you see? Okay, Pascal's triangle. All right, do you see the set of natural numbers there? Yes. Do you see the triangular numbers there? Yes. Where are they? Do you see them? It's now obvious. Do you see? They are all related. They can be found in Pascal's triangle. All right? So, for your assignment, I want you to think over these questions. What if the difference stabilizes at the third level? Which methods can be used to arrive at the nth term? Of course, we will use that trial and error. Can we use the formula for arithmetic sequence? Not anymore, okay? Can we use, what other methods did we use?
The visualization.
Visualization, yes. Visualization maybe, no? Can we draw squares or dots there? And will the method of finite difference work? Do you think it will work? So you think about it. Now, how will the function look like? Will it still be linear? Will it be quadratic? Or what would be the exponent of the first term, which is n? Will it be n squared, n cubed? So I want you to experiment on that. If we have polygonal numbers, do we have polyhedral numbers? Polygons are two-sided figures, and polyhedra are three-sided figures. Do we have those? Can we have a formula for the nth term? That's for you to think about. So I'll see you all next meeting. Goodbye, class.
Goodbye, ma'am.